Today we're estimating angles. When I have a look, I can estimate the size of an angle. This one, I have two rays. One ray looks perpendicular to the horizontal ray. I can say I estimate that to be 90 degrees, and it'll look like that. When I'm looking at this one, I'm thinking that must be close to 45 degrees. What I do is I can have a look at 5 centimeters this way, and if I measure 5 centimeters up that way, I should actually hit the ray, and I will know that this is 45 degrees. I know this because if this was a block, a 45-degree angle will make a ray that will go from one corner to the other corner of a square. 45 degrees. I'm looking at this one. I'm thinking it's a little bigger than 45 degrees. If I have a look at my 5 centimeter rule, I'll go 5 centimeters there, and if I go back up 5 centimeters, I will see that it has landed a lot short. 45 degrees would be there, so I'm guessing that this one is about 60 degrees. Looking back at a right angle, we know the right angle is 90 degrees. If I divide my 90 degrees into 3 sections, each section being the same size, I would now have 30 degrees, 60 degrees, and 90 degrees. Looking at an angle, dividing it up into 3, I can estimate a 60-degree angle or a 30-degree angle. If I'm looking at an obtuse angle, this one is very close to a straight line. Here we go. I can see that that is just under 180 degrees, maybe 10 degrees under. I guess that one to be 170 degrees. Clock faces often help us with our angles. We know that when it's 3 o'clock, we have a 90-degree angle. Once again, if I divide that up, at the 2 o'clock, I would have a 30-degree, because if I divide it up at the 1 o'clock, my 90-degree angle is divided into 3 parts: 30, 60, 90. Using a clock makes division of angles easy. My 6 o'clock is in a straight line, so I know that's 180 degrees. When I'm looking at 9 o'clock, I have 90 degrees this side, but on the outside, I have a reflex angle of 270 degrees.